Hello everyone. Let's take a look at our next problem. What is the area of an n-sided regular polygon inscribed within a circle of radius r? So this should just be a straightforward geometric computation, which means I'm going to start by drawing a picture. Close enough to a circle. So we have, and what I want to do here is, if we have an n-sided regular polygon, then that can be written, that can be decomposed into n equivalent or congruent triangles. So, if our polygon goes around like this, imagine that everything is completely symmetric here. The fact that I'm drawing it very badly might actually, it'll help us, prevent us from assuming things that are not true. If we call that angle theta, then theta is equal to 2 pi divided by n. The length of one of these sides of the triangle here is r, that's the radius of the circle. And so what we need is the area of one of these triangles, and then we just multiply by n. So all of these angles around the center are intended to be the same, because it's a regular polygon. If I take one of these triangles and let's draw it a little bit more, a little bit nicer down here so we can compute the area of this thing. That angle is theta, this length is r. If I drop a perpendicular down, then we've got theta over 2 on both sides. And what we really want are the height and this half base length. So what can we write here? So tan of theta over 2 is x over y. And the area of this entire triangle, the whole triangle, not just one of the halves, is 2x y divided by 2, right? Okay, so it's just xy, because we need the entire base, which is 2x, multiplied by y, and then it's a triangle, so we divide by 2. So we can rewrite this as x is equal to y tan theta over 2. So the area of one triangle is y squared tan theta over 2. And y squared, or y, what's the relationship between r and y? We have cosine of theta over 2 is equal to y over r. So y squared is equal to I think now that I'm writing this all down, there was probably a much more straightforward way of doing all this, because I see I'm going to get get things multiplied by other things here. Whatever, let's just continue. A is equal to y squared r squared cosine squared theta over 2 times tangent theta over 2, but tangent is sine divided by cos. This is a surprising expression to me. And in fact, that's almost certainly false, right? I've done something stupid. What have I done that's stupid? I'm sure I've done something stupid. I'm not going to delete this, just in case I'm stupid for thinking I'm stupid. Let's start with one of these triangles again. So tan of theta over 2 is x over y. Cosine of theta over 2 is y over r. And sine of theta over 2 is x over r. The area of this entire triangle is xy, which is r sine theta over 2 times r cosine theta over 2. This, oh, no, okay, I see why I thought I was wrong before. Okay. Ultimately, we're going to have to multiply this thing by n. Okay, so that's the area of one triangle. So the area of the entire polygon is n r squared times sine of this angle. Remember, I'd said earlier that theta is equal to 2 pi over n. So this is pi over n times cosine pi over n. Yeah, I thought I had a mistake somewhere, like an extra factor of either sine or cosine, because of course as n goes to infinity, this thing converges to 0 because we've got a 1 over n in here. But I forgot that we're ultimately going to be multiplying this thing by n. And of course, as n goes to infinity, you expect the n-sided polygon to converge to the radius of a circle. And you can kind of see that here, right? That will go to 1. There's the r squared in the area of circle formula. And then the product of these two things as n goes to infinity, I guess will go to pi, right? It's like a sine x over x type thing, but there's an extra factor of pi in there. So there we go. That's the area of a regular polygon inscribed in a circle of radius r. It's a nice problem. Thanks for watching.